Now, the next one is going to be very expected by a lot of people. And before I give Nate the chance to start sharing, I would like to tell a story. So a lot of us in the community, we are trying our best to provide the best of the experiences to people. However, we get a lot of questions on, oh, can I have this plugin? Can I have this plugin? So we invented something called Eric, and people went completely crazy with this concept of Eric. That will be a way to interface a buffering radio with ATAK. So we made jokes of that, and one day I discovered that in fact we had something called Eric or similar, and today Nate is going to present that to us. So it's a lot of people that don't even believe today that this is real. So Nate, it's now up to you to convince us that this is not anymore a joke. Go on.
Sounds good. I'm glad we're not holding this on April Fools. All right. Are you guys able to see my screen now?
Yes, we can. Go on.
Okay. Well, thanks, Drew. So yes, I'm Nate Soule, and I'm glad that you told the story there, because I've heard it alluded to, but I wasn't in on some of those initial conversations, and several people kept telling me that, is it a joke that we're presenting this today? So no, this is real. We've been calling it Hammer, though maybe we need to have a vote as to whether it should be Eric or Hammer. But anyhow, I guess let me step back for a second. So I'm Nate Soule. I'm with Raytheon BBN Technologies, and I tend to work in the space of developing tools in the TAK ecosystem, building on the TAK ecosystem, kind of on the edges of the TAK ecosystem. And so I'll talk about one of those today, and that's Hammer, which is really an open source software modem that's built as a plugin for ATAK. So hopefully I'll be able to convince you that this is real with some screenshots and other things going forward. But just a quick sense here, what we'll cover, starting just with a little bit of background and the problem space as I see it. But it sounds like there's been a lot of community discussion about this. So folks on the line here might be able to even tell me the space is broader and there's more general applicability than I'm even targeting here. But then we'll get into Hammer, and I'll give an overview of what it is and how it's used. I'll talk about the design and architecture, not at a very technical level here, but just talking about how open source software and reuse is really playing in. Tell you a little bit about the modem internals, but won't again go in depth there in part because of the nice properties of how open source works and the reuse we were able to do here. We were able to treat some of these kind of things as black boxes and really not have to dig into as many of the internals as you might think. Then I'll talk about how you can use this, how you can change it, how you can extend it, a little bit about the license model that we're using, and go from there. So I'm sure this will come as no surprise to anyone here that in order to use ATAK to share information with another ATAK, you need to have a network. This could be tactical radios, Wi-Fi, LTE, whatever it might be. But what we wanted to answer was, is there a way to do this if you don't have the traditional kind of networks that we think of when we're using ATAK? So what if we can't count on network infrastructure? LTE is not there, for example. We don't have Wi-Fi, or we might have some kind of communication mechanism, but it's not an IP network. Or we've got IP radios, but they're not compatible. So it was in this space that we started thinking about Hammer. And if for those of you that were at the TAK conference last week, I briefly alluded to this here in the context of a set of search and rescue tools we're building. And so that's kind of where this stemmed from for us, but we quickly realized that there's a more general capability here. So Hammer stands for Handheld Acoustic Modem for Mobile Exchanges with Radios. And again, maybe we can have a vote to see if it should stay as Hammer or go to Eric now that I know about Eric. But really, this is an open source software acoustic modem that we built as an ATAK plugin. And really what it's doing is enabling you to take the digital data that's sitting in your ATAK device, send it to another ATAK device, is with the only requirement being that there's a voice channel that you can use. So the figure on the bottom here is really trying to depict that. So you've got your ATAK device on one side, and pick your favorite off-the-shelf radio here. We were testing with a set of radios you get off Amazon for a 4-pack for $50. I know people in the chat thread earlier, I think, were asking about Baofangs, and we've tested with those. So this is your off-the-shelf radio and ATAK. There's no additional hardware here. I call it a modem, and people sometimes will think of that as a hardware thing. But here, this is pure software. It's a plugin running with an ATAK, and you can use it in two modes really. You can use this with a cable where you're connecting the speaker from your ATAK device to the microphone of the radio, and the microphone of your ATAK device to the speaker of the radio via a cable. And in that case, there is no audible noise made when you go and send some data. It's going to go over the voice comm channel provided by the radio, but you as a human sitting there are not going to hear any noise. But if your radio doesn't support that, if you don't have the appropriate cables or the appropriate jacks on the radio to do that, then you can do this with audible noise and just with your ATAK speakers and your Android devices speakers and microphone. In that case, it will sound, particularly if you're sending lots of data, like the early 1990s, and you'll hear that fun modem sound. And that might not be applicable for some scenarios, but in others it works just fine. We tested here with things like lawnmowers and other background noise, and actually did see still a good effective communication there. So it is relatively robust to noise, but if you're able to use a cable, clearly that's going to reduce the impact of background noise and give you a overall higher effective throughput.
And I'm getting some questions in regard to the bandwidth that we can expect.
Yeah, it's a great question. I'll give a multi-part answer here. One is what is reported on, so the open source software modem that we are taking advantage of here, and I'll point you to in a couple of slides. Talks about something on the order of 80 kilobits per second as a bit rate. Now, whether we've seen that really come to fruition or not, I can only speak to anecdotally at the moment, because one of the next steps that we really need to do is do a formal analysis here and see what really is that operating envelope, where how much bandwidth are we actually getting, what as message size increase, how do error rates increase, and where's the sweet spot. And some of that will be dependent on the tool and the software, and some of that will be dependent on the radio, and some of that will be dependent on the background noise and interference that you might be experiencing. So there's a lot of variables that go into answering that question. You're not gonna be streaming video, that's for sure. Maybe sending small images. We've been using it to send COT markers with relative ease. So it's at that level that you want to be thinking. But I'm hoping that I will have a more confident and formally, rigorously evaluated answer for folks in the not too distant future here.
Another question that is coming in the chat is in regard to having some kind of meshing, and if that is planned or you're thinking about it.
Sorry, some kind of what?
Mesh network. So the ability to bridge the signal to another radio so that we can extend the network.
Right. So at the moment, everything that we've been testing with is going to be kind of pure broadcast. So if you're out there and you can hear the signal, you can you can receive. And I should, as part of that sentence, probably say one of the other things that we need to add here in the not too distant future is encryption on top of this, because right now there is none. We're just sending, for example, if you send a COT marker, we will send just the COT, and anybody who's listening can receive that. Now, if you wanted to have a mesh network that you were building out of this, that is not something that we have tackled, and is because of the way that the types of radios that we've been testing with, at least, are working, that would probably be a challenging thing to do, but not necessarily an impossible one. And so, I guess the answer is we haven't gone down that road, so there's nothing there at the moment, but certainly be interested to talk with folks more about doing that. And because we're releasing this open source, I would encourage people to take it and build it and try to do that as well.
Thanks, Con.
Okay, great. So what you're looking at now is a set of screenshots from the tool. Right now, you are able to just send COT markers. And this is really a limitation of the amount of time that we've had to build out the ATAK integration, and not a limitation of the underlying modem or the radios or anything of that sort. Really, it's just we started with COT markers and hope to go soon to other things like chat, sending small imagery, things of that nature. We, at the moment in the tool, when you are sending COT markers, you can do it in one of two ways. One is open up the ATAK plugin tool through the overflow menu in ATAK, click on the hammer icon, and it'll present you a list of COT markers that are currently on the map, and you can tap on one to send it. A more intuitive way for a lot of use cases is that you can instead tap on the markers on the map themselves, and then you'll see the hammer icon appear in the radial menu, and you can then tap on that to send it as well. So either way will achieve the same effect, and they're just two different mechanisms. Within the hammer tool itself, you can also toggle on and off whether you are receiving. The tool will intelligently stop trying to receive, as it wouldn't be effective while it's transmitting, but it'll then turn that back on as soon as you're done sending.
And we have a question in the chat in regard to timing. So do you have any kind of timeout that, for example, you cannot flow the channel with over a certain amount of markers, or any limitation like that?
So right now, we are not trying to throttle the sending, and that's in part because there is no auto send feature at the moment. So it is a human required, there's manual steps that you have to take, a few different clicks here and there in order to send something. And by the time you're done sending, actually executing those clicks, your channel's probably open again to send. Now, if you're using walkie-talkies and or something of that nature, and are in a world where you can't, multiple folks can't transmit and receive at the same time, then you can have those kind of conflicts across users. So if there were 50 folks with radios, this might not be well suited for that. You might get a lot of failures, a lot of collisions, just as you would, if you were just trying to use them with voice. Folks have probably experienced that firsthand. So there can be that kind of inter-device collisions. We're not at the moment trying to do any throttling across the channel, like I said, in part because it's hard to saturate it fast enough as a human. Though you could just keep, if you're looking at that list up in the top right there, if you just tapped on each one of those sequentially, I suppose you could. But we just queue them up and send them out one at a time. So you could get a rather large queue, but they'll still send out effectively. And
I got a very interesting question in this regard from Krusty on the chat. It asked if Hammer is going to listen before transmitting to prevent packet crashes.
If Hammer is going to listen before transmitting, was that the question?
Yeah, because if the channel is busy, clearly it's going to, That is the limitation of radius, right? That the channel is only, yeah.
Yes, and right now you will be queued if we are currently, if we've detected that we are receiving a message, your transmit will be, wait until that is done. And then once you begin to transmit, we stop trying to receive for that short period. So you could have a collision still in that case though.
Okay, very good. And I got another question from Jan. Do you think that this is a initial release, or you will consider still a prototype? When is that we can expect a release?
Yeah, great question. So we are in the, this is, there's a repo in TAK maps for this, and we're getting this signed and trying to get it pushed out onto the Play Store. We are also just on the cusp of actually posting this, the open source, the source code itself. And so all of that will be coming imminently if it's not there already. And the kind of the level of maturity that I would consider this is, it works, and we've tested it in a number of different scenarios with a small handful of different radios, but it has not received 100 hours of testing. It has only been the developers really that have tested it to date. So we would happily request that folks become testers for this and try it out. Let us know what works, what doesn't, what kind of other integrations you'd like to see. And because it is open source, you can feel free to make those changes and extensions and enhancements yourself, or we would certainly be happy to take feedback on the BBN side and make some of those changes that if we see them kind of common across the community. So it's I don't know if beta is the right word, but it's out there, it's usable, it functions, and it just hasn't seen a wide array of testers to date. So so use it your own risk here, I guess, in the near term, but it's certainly functional, and yeah, I would welcome any feedback that folks have.
Thank you. Go on.
Okay. So next up was what I was calling design and architecture, but this is really not at the level that someone might think of this. There's no boxology and no flows between subcomponents or anything shown here. Really what I wanted to get across here was that this is a story of reuse, and that 3 of the 4 arrows that are leading into what became the Hammer plugin were things that I didn't need to write a single line of code for, or the rest of the team that I was working with. We started from ATAK and the SDK, and we took an open source audio modem on GitHub and pulled that in. And what we really needed to write were the integration hooks for ATAK to be able to take a marker on the map, take some COT, turn it into something that we can serialize and send over the out through the modem, transmit over voice comms, and then receive on the other side, and just hook into ATAK's mechanisms for sending and receiving. So on the receive side too, we want to be able to receive a message, turn that back into a marker that we place on the map, for example. So the story here is that we really did not have to put in anywhere near as much work as it might sound like to make this come to reality, because we're building on a system like ATAK, and because we're able to take advantage of some open source tools out there. And for those that are able to stick around into some of the later sessions today, I'll have another talk that's on a similar subject, but really now I'm talking about Hammer, what is it and how do you use it, and talking about it as a tool. The talk later is more using Hammer as a case study of both using open source software and releasing something as open source software. What are some of the considerations you might need to take into account when doing either of those things, and talk about the experience we had in both consuming open source and in releasing Hammer as open source. So I think that there was just such a nice story in that open source and platforms like ATAK just made this really pleasant and easy to develop.
And some users are wondering which project are you using as a software model from GitHub. Can you share that with us?
I can, and it's on the slide now. So this is something called the audio modem for Android, which is really just based on something called the audio modem communications library. There's a link here to GitHub, and if you go out there, there is a link from that page. There's almost no README on that page, but if you click on that, on the link that's there to the audio modem communications library, you'll get taken to something that talks a lot more about the modem. The original version of this was developed in Python. Then the authors created a Java version, and then they took that Java version and converted it to something that was at least Android friendly. So it had a lot of the features that we needed right out of the box, came with an MIT license, so it made it very flexible and easy to use. It shows some of the specs. These are directly from the open source modems GitHub page, but this is using something called orthogonal frequency division multiplexing, or OFDM, which is really a digital signal modulation method that splits a single data stream across several narrowband channels using different frequencies. And what this results in is a similar throughput as if you had a single channel, but reduces interference, allowing the symbols to be more accurately received. So you might get the same actual theoretical throughput as some other methods, but your effective throughput goes up. You get a little bit better accuracy and fewer retransmits. One thing that's important to note here, though, I guess, is we are using this as a kind of a raw tool. We will send some COT out, and the other side will hopefully receive it. And there are things like CRC32 checksum that can be used to ensure that it was received correctly. But we did not build a protocol on top of this that would do something like acknowledgements, for example. And so the sender will send, and the receiver will be able to, if they receive any part of it, will be able to know whether they received it correctly or not. But the sender won't know for sure that it was received by the other side unless the other side is able to send a message back. And I'll talk about this in just a moment, but one of the things that I would really love to do on top of this is open this up as a library that is geared towards ATAK, but that other plugins can use. So what we've built now is the user-facing tool that will allow an ATAK user to employ this, but I could see other folks wanting to use this more as a building block to build more complex data sharing systems. So I'll mention that in just a moment.
And we have the last 5 minutes.
Okay, great. I think I'm on the last or second to last slide here, so I will move through this quickly and make sure we've got some time for questions still. So a lot of this I've actually mentioned already. The current limitations of sending COT markers is really just an artifact of what we've built to date and where we've integrated into ATAK. But I can see chat being the next thing that we want to be able to do here. Sending small imagery, things like that are on our near-term radar. The modem itself can send arbitrary byte streams. So again, the current limitations are not a limitation of the modem or the radios. We have done some ad hoc testing, sending 4 kilobytes of data in a single send, and that actually worked pretty well. And like I was saying, it even worked well with things like lawnmowers in the background. That 4 kilobyte number is just where I stopped testing, not a limitation where we saw poor performance above that. So you'll see in the next steps here, we'd really like to do a formal analysis to see at what point do things start to degrade, what really is the throughput we can expect with different types of radios, and then start to build hooks for chat, for images, and other things. I'd love to hear from people in the community that, what other kind of data items within ATAK would be useful to send. So here, this is just talking about how you can use, how you can change, how you can extend Hammer. So like I said, it's going to be out on TAK maps available for Civ, Mill. This is open source, so it's essentially public release here. In terms of changing and extending this, we are using a GPL v3 license, and in the talk later this afternoon, one of the things I talk about is how do you pick the license you want to use, and I'll talk a lot about why GPL v3 was used here. But the piece I was mentioning earlier is we'd love to open this up as an API so that other folks, other plugin developers can use this as a raw transmission and receipt capability and build new things on top of that. So between the fact that it's open source and this kind of API, we'll be able to allow people to use it as is, because I think already it will allow you to share the points on the map, and soon hopefully other things. Allow you to use the API, so use it from another plugin, and because it's open source, allow you to change it or embed it and use it in other plugins. Oh, and actually, I guess I do have one little bit here about why GPL3 and what that means. So well, I'll talk again this afternoon about how GPL3 relates to other license models, but this means that it can be used and modified, but and there's some fine points here that I won't go into at the moment. By default, if you're using or modifying this directly, you can expect your code to then inherit some of the GPL v3 constraints. Now, here I say the DoD has an unrestricted license. Ralph pointed out earlier, a good point, that this is really the federal government does. And so if you are working with or for the US government and want to use this and change it and not inherit some of those GPL v3 constraints, you're in the lucky position that you can do just that. So if this is for government use, there's even more relaxed constraints than GPL v3 would otherwise impose. And I think with that, that's all I had. I know there's only leaving a minute here now for additional questions, but happy to take them.
So you got a ton of questions. I will, because we are already out of time almost, I will ask a couple of them, and then I will invite you to look into the Reddit to answer additional questions, because people is getting crazy. So one very interesting question is, can we currently send the position of the user periodically, like we will do with a GoTenna? Because that is the main information for most users. Is that part of the current release?
So in the current release, you can do that, but only if you do it manually. So you can tap on your own icon or select it from a list and send that, but there is not a, hey, please send this out every 5 minutes option. We had talked about doing this, and when we, at the time, we were still testing with some different cables that were going to automatically trigger push-to-talk functionality, and we had put that on pause. So that's something I know that would be useful, and at this point would actually be relatively trivial to build, but it's not there at the moment. So I guess I should add that to the list of things that we should really do with this in the immediate term, because just like chat, I can see that as being one of the kind of key use cases here. So the answer is yes, but only manually, but hopefully in the not too distant future, you could do this automatically.
Okay, a last question. How long will it take in milliseconds to send 4 KB to another radio? Have you made any metrics?
Yeah, again, only ad hoc here, and I don't have the numbers in front of me, but think of something on the order of, I think of this, I'm going to get this wrong, I'm sure. It's smallish double-digit seconds. So 15, 20, I can't remember for sure if to send 4 kilobytes, I think. I'm pretty sure it was north of 10 and south of 20, but don't quote me. And as soon as we do that formal analysis, I will be happy to post those results to the GitHub page so that people can get a sense of what's really feasible to do.
Okay, thank you, Nat, for this presentation. As I said, this has a huge impact on this community. And by the way, we got here a kind of popular opinion that the name Eric should be kept in some ways. So people say that maybe you can use Eric the Hammer or any other variation, but they want to have Eric. It's too funny to,
All right,
drop.
I like it.
Okay.
We're gonna have to figure out what an icon for Eric looks like, but sounds good.
Oh, we have a lot of creative people here that will be very glad to provide you icons. Okay, thank you again, Nat, and